Write the expression for the reaction quotient. QC like the equilibrium constant expression. The reaction quotient QC is calculated using the initial concentrations of the products divided by the reactants, each raised to the power of their stoichiometric coefficients from the balanced equation. 3O2 is an equilibrium with 2O3 QC equals O3 to the power 2 over O2 to the power 3. Substitute the given initial concentrations to calculate QC. Using O2 equals 0.150 molar and O3 equals 2.5 molar. QC equals 2.5 to the power 2 over 0.150 to the power 3. QC equals 6.25 over 0.00337, approximately 1.9 times 10 to the power 3. Compare the value of QC to the equilibrium constant, Kc. Compare your calculated QC with the given equilibrium constant Kc equals 1.8 times 10 to the power minus 56. 1.9 times 10 to the power 3 gg 1.8 times 10 to the power minus 56. Therefore, QC greater than Kc. Predict the direction of the shift to establish equilibrium. When QC greater than Kc, the ratio of products to reactants in the current mixture is much larger than it should be at equilibrium. To decrease this ratio and reach equilibrium, the system must convert products back into reactants. This forces the reaction to shift to the left, the reverse direction. Determine the effect on the amount of O3. Because the system shifts to the left, the product O3 is consumed, its amount decreases, while the reactant O2 is produced, its amount increases. This confirms option D is the correct answer. The correct answer is option D. The amount of O3 will decrease because Q greater than Kc.